welcome everybody. We're at the University of Waterloo, Ontario District event. I'm here with Eden, Jackson, Thomas, and Serge of Team Dave, number 3683. And they're gonna talk me through some of their changes that they've made since Niagara, how they do their autos, and the different subsystems of their robot. Okay, so you guys have a 4-piece coral auto. How did you guys come up with that? How do you use that 15 seconds so efficiently?
Yeah, so we knew that auto was really important. Last year we had some struggles with it, so this year we changed the way we make our autos. We no longer use Path Planner. We use PID to points. We saw OP 2056 used it last year and it worked really well for them, so we decided to copy it and it's worked really well for us. The way we decided to score, the order that we score in, is basically to minimize driving time. So we score the far back L4 and then we do the two that are directly driving from the source, and we go back to the back left again. The reason we decided to go to the back left is that a lot of teams like 2056 have 4-piece autos that will end up scoring on the front of the reef, and we knew that in order to work around that, you can't fit 2 robots in front of the reef, and so we can score on the back instead, and then we won't hit each other. Awesome.
Now, do you just score on the left, or if you're on the right
yeah,
driver's
we
station?
can score on the right side as well. It's the same thing. We score the 4 on the right side, and we don't go to the front because we want to stay out of the way of other teams to maximize production scores.
Cool, thank you very much. So I heard you guys made some improvements since Niagara on your ramp. Do you want to walk me through that and how that works?
Yeah, so at Niagara, one of the main things that was a problem was when we would feed it in, it would kind of bounce out. So we added this in just so that now we can feed it from farther away and it'll go in more consistently. We have these 2 sensors here, so we can track where the coral is when it goes in, and then we can also use this to unjam. When it goes in sideways, we're able to get it oriented the right way, and then we're also able to hold the coral in here while we have the algae, so we're able to do hybrid cycles, which improves the efficiency of the cycles.
Awesome, thank you. Okay, and then if you were to shoot it out. Awesome, so you can hold both at once. Cool, cool. So do you want to explain to me the elevator subsystem of the robot?
Yeah, so we have a 3-stage elevator, and we use continuous in-tube belt rigging to run it. So we also have 2 Krakens at the bottom of our elevator, which we use to power it, and they use a 3-to-1 gear ratio. We also have 2 tie rods on each side to help make the elevator more rigid. And so we have the gantry on it, and it can lift up to max extension in just over half a second. And yeah, that's about it for our elevator.
Wow, that's really fast. I noticed you have a constant force spring over here.
Yeah.
How do you retain your wires when going up and down?
So when our elevator extends up, this kind of helps us so it won't like flop around as much. And
yeah, do you want to go ahead and extend?
Just show the elevator. You can see that it really just like comes right back, which really helps us to make sure that we don't like get stuck on anything. So
awesome, thank you very much. Okay, so Jackson here is going to explain the gantry system.
So we hand off coral from our ramp and we grab them with our 6 I believe these are Thrifty rollers, no, Andy Mark rollers, and then we have these belted together and they're driven from an Kraken X44 that also runs our roller for our pivot to hold our algae. We have bevel gears on here so that we can transfer the rotation from the roller to our other wheels.
And those look 3D printed. Are they
yeah,
hot parts or they're custom?
They're 3D printed, but we take the design from McMaster.
Awesome.
And then we have on this side, we have an X60 running a pivot. So it's bolted onto our Lexan plate and it just allows us to rotate. And then for our roller, we have a system of belts and tensioners that allow us to travel up the curve, as well as a gear exchange. And then it just back drives to hold in the algae.
Do you want to show me it running? That's awesome. And I noticed that your roller that you used to hold algae went down when you went to hit that L1 coral.
So
What's that for?
it allows us to redirect our coral from a diagonal state more to a horizontal, so it more easily sits in the trough.
Awesome. Cool. Thank you very much.